Alright, 4.3, number 11. It's a big daddy. So I did it earlier today, and then my recording device didn't work, even though it said it was working. So I'm doing this again. So of all the problems for it to fail, I'm not real thrilled about doing this one again. Alright, so 4.3, we have to analyze it all with the assumption that we're not using our graphing calculators at all. So first step is to find first derivative. So y prime equals, do a product rule x times the derivative of that, which is 1/2 8 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x, plus square root of 8 minus x squared times the derivative of x, which is just 1. So y prime equals 1/2 negative 2. So 1/2 and 2 disappear. I have an x. So I have a negative x squared over square root of 8 minus x squared plus the square root of 8 minus x squared. Maybe I'll just find the point where we have horizontal tangent, or extrema, potential extrema, by setting it equal to 0. We could combine these into one term if we wanted to. I'm just going to leave it separately right now and solve it. So I'm going to add this to the other side. So x squared over square root of 8 minus x squared equals the square root of 8 minus x squared. And then I can just multiply by the square root of 8 minus x squared. So x squared equals, that times that is just 8 minus x squared. So 2x squared equals 8, x squared equals 4, so x equals plus or minus 2. So we have, these are potential x values, critical points. I'll call it extrema. Okay, so I know that there's a horizontal tangent at 2 and negative 2. And 2 and negative 2 are in the domain. So that I know. I think I'll maybe work with this or just in one term and then find the second derivative. So I'm just going to, y prime is negative x squared over square root of 8 minus x squared plus so common denominator, you could do it over 1 and then multiply the top and bottom by the square root of 8 minus x squared. You're going to get 8 minus x squared over square root of x, or 8 minus x squared. So now they have a common denominator. That's a little trick. So then we can combine. So negative x squared minus x squared, so that's negative 2x squared plus 8 over square root of 8 minus x squared. We're now ready to find the second derivative, which will be the quotient rule. So bottom times the derivative of the top minus the top times the derivative of the bottom, which is 1/2 8 minus x squared to the negative 1/2 times the derivative of the inside, which is negative 2x. All over the bottom squared, which eliminates the square root. Alright, there's my second derivative. Got a little cleanup to do here. So I'll go negative 4x square root of 8 minus x squared. I have a minus, I have a negative right here, so that's a plus. 1/2 and 2 undo each other. So I have an x, so plus x, negative 2x squared plus 8 over square root of 8 minus x squared all over 8 minus x squared. Alright, so I have a fraction inside of a larger fraction, so I'm going to multiply the top and bottom by square root of 8 minus x squared, square root of 8 minus x squared. So if I distribute that, this one times that one is just going to be 8 minus x squared, so negative 4x times 8 minus x squared. And then these two will divide out, so it's just minus 2x cubed plus 8x over, so 8 minus x squared to the first times 8 minus x squared to the 1/2 is 8 minus x squared to the 3/2. That's my second derivative. Still cleaning it up. I've got negative 32x plus 4x cubed minus 2x cubed plus 8x. So y double prime is 2x cubed minus 24x Okay, so there's my second derivative. Might as well try to find our inflection points. So to do that, we want to set the second derivative equal to 0. If we're going to set this equal to 0, really all we have to do is set the top equal to 0. So, because a fraction can only be 0 if the top is 0. I can factor out a 2x, left with x squared minus 12. So x equals 0. So x equals plus or minus the square root of 12. Okay, so those are our potential inflection points, the x values of the inflection points. If we go back and we look at, actually we could might as well find the other potential inflection points at this point. So you can have an inflection point where the second derivative is 0 or is undefined. So whatever makes the bottom 0 will produce an undefined second derivative. Well, if x is the square root of 8 and negative square root of 8, so x equals plus or minus the square root of 8, that will make the bottom 0. So all three of these are potential inflection points. Alright, so now let's go back to our original equation right here, and if we talk about the domain of this, you can't have a square root of a negative number, so 8 minus x squared has to be greater than or equal to 0. Well, what will make it 0? Square root of 8 will make it 0. If x is the square root of 8, you get 0 there. Or negative square root of 8. If x is so square root of 8 is less than 3. If x is 3, you see that we would get a negative inside the square root. 8 minus 9 gives you a negative. So x, the domain of this is only between the negative square root of 8 and square root of 8. So the domain is only between negative square root of 8 and square root of 8. So square root of 12 is outside the domain, so those are not going to produce inflection points. And negative square root of 8 and square root of 8 are the endpoints of the function. So you can't have an inflection point because it can't change concavity because it doesn't exist beyond square root of 8 or negative square root of 8. So those are not inflection points either. So x equals 0 is the only x value that produces an inflection point. If we go back and look at our potential extrema, one thing I could have noted is if I find my derivative, what will make the bottom 0 square root of 8. So plus or minus square root of 8 are two other potential extrema because that's what makes the bottom 0. So plus or minus 2, plus or minus the square root of 8. Okay, so let's as long as we have a second derivative, let's plug in our extrema into our second derivative. So do a second derivative test here. Zoom out so you can see more of it. So y double prime of negative 2 and y double prime of 2. y double prime of square root of 8 and negative square root of 8 is going to be undefined, so we don't have to plug those into our second derivative. So if I plug negative 2 into our second derivative, 2 times negative 2 cubed minus 24 times negative 2 all over 8 minus, anyways, you would get, let's see, you would get y double prime of negative 2 is 32 over 8, which is 4. So what's important about that is it's positive, so it's concave up. So therefore it's going to be a minimum at that point. So negative 2 is going to produce a minimum. If I plug 2 into my second derivative, I'm going to get negative 32 over 8, which is negative 4. That's concave down, therefore it's going to be a max. We might as well find the ordered pair here. So negative 2, let's find y of negative 2. If I plug negative 2 back into my original function, negative 2 times 8 minus negative 2 squared, so 8 minus 4 is 4, square root of 4 is 2, times negative 2 is negative 4. And y of 2, if I plug 2 into my original, it's 2 times square root of 8 minus 4, so 2 times 2 is 4. Okay, so at negative 2, it's a minimum. So negative 2, negative 4 is a minimum, and 2 comma 4 is a maximum. 2 comma 4 is a maximum. If I plug 0 from our inflection point, if I plug 0 back into our original equation, I plug 0 in right here, and here I get 0. So I have an inflection point at 0 comma 0. I think it's time to make a sketch. So once we have our sketch, we'll be able to answer all those questions pretty easily. Okay, so we know at 0 comma 0 is an inflection point. Our end points are square root of 8 and negative square root of 8. If I plug those back into the original equation, I get 0, because 8 minus square root of 8 squared is 8 minus 8, which is 0. So both at negative square root of 8 and positive square root of 8. So square root of 8 is between 2 and 3. Probably it's closer to 3. So I'll say 1, 2, 3. This is square root of 8 comma 0. And this would be negative square root of 8 comma 0. Those are those 2 points, kind of the endpoints. I know that negative 2, negative 4 is a minimum. Negative 2, negative 4 is a minimum. Negative 2, 1, 2, 3, 1, 2, 3, 4. And then 2 comma 4 is a maximum. 2 comma 4, 2, 4, 1, 2, 3, 4. Somewhere up there. I know it's concave down at that point. I know it's concave up at the minimum. Nothing else interesting happens, so we can look at it. There's my sketch. Notice that there is an inflection point at 0, 0. It changes concavity. So based off of my sketch now, I could say that it increases between negative 2 and 2 because it goes from minimum to maximum. So it increases in the interval negative 2 to 2. It decreases before negative 2, so negative square root of 8 to negative 2, and then after square root of 8, so negative square root of 8 to negative 2, negative square root of 8 to negative 2, and then from 2 to square root of 8 is where it decreases. It's concave up on the left side here, so from negative square root of 8 to 0, please. So it's concave up from negative square root of 8 to 0. I'll write that down. You don't have to watch me write it down. It's concave down from here to here, so from 0 to square root of 8. We've got an absolute minimum at negative 2, negative 4. Absolute minimum, it's equal to negative 4 at x equals negative 2. We have absolute maximum equal to 4 at x equals 2. We have a local maximum equal to 0 at x equals negative square root of 8, and we have a local minimum equal to 0 at x equals square root of 8, and the only inflection point is at 0. So there's my chart of answers.